Hello everybody, this is my presentation about how to integrate barcode and RFID readers with Delphi, in special for mobile applications. My name is Fernando Rizzato, I'm a software consultant for Latin America. So this is our agenda for today. The idea is to understand the motivations, why someone needs or wants to integrate this kind of device with a mobile application. We are going to review some integration models and some devices that we tested here. Of course, samples, and at the end we have a session with questions and answers. So some initial considerations about this work. First of all, it's important to mention my tests are all based on Android devices. So it's possible to integrate as well for iOS, but it's a little bit more complicated, especially because some restrictions that iOS has for Bluetooth. So there are specific profiles that are not implemented for iOS and etc. I put here this link where you can find more about those restrictions. Also, it's important to understand some versions of Android, especially 4 and 4.something, they don't behave as expected in some situations, especially using like integrations with intents that we are going to see today. Like in these models for Zebra, we test this. Some customers actually test these two models and has some instabilities. So customers want to use barcode readers. Some of them wants to use RFID readers in their application for inventory, stock control, and etc. Of course, you can use or you can read barcodes using your mobile device, but this has a limited efficiency. It's not like good in terms of performance. In any case, let's review how you can do this, how you can read barcodes with your own device, your own mobile device using this zebra crossing library. So zebra crossing library, it's an open source library for barcode scanning. It was created for Android based on Java, of course. But if you go here to this GitHub repository, you have all the details about the library, of course, and you can download the clone, etc. But as well, we have here a list of ports of available for this zebra crossing library, like Qt, C++, and Delphi. So we have zebra crossing library available for Delphi, not only from FireMonkey, but also for VCL. So in this repository here, we have the Delphi version of the zebra library. As well, you can find some demos. So I went ahead, download this, and if we go here to this VM where I'm running my Delphi Rio, I like to show this library running just in case you want to use this for a basic integration with barcode reading. So I have here a group of projects that we are going to explore today, and this is the first demo. So the integration is very basic. You need a camera component. Of course, this sample has the code that is necessary to handle the permissions and etc. We're not going into these details right now, but basically here we can activate the camera, check for the permissions and etc. and activate the camera. There is a class, the scan manager, and we are creating here the scan manager. And on the camera component, we have the on-sample buffer read. So this is the moment when a frame of the image is available. And we are using here a thread to synchronize this method, the get image. So the get image will grab a frame of the image and submit this through the scan manage, and the library will do all the work for you, will generate you the code, the image, and give you the value of the barcode. Basically, this is what's happening here. Of course, this is in this method we are using a parallel task, right? So this runs in parallel, so your application don't freeze, and this scan process can take some time. So we are running this in parallel and updating the interface with the results. So if you run this on my Android device, I'm sharing here the Android device so you can see the application in action. Just some seconds more. Here we go. Let's start the camera. Let's give it the permissions and capture the barcode as you can see here down below. So this just works and works really fine. Another way of integrating the zebra crossing library with the in special Android application is using intent. So there is a version of this application, this zebra crossing app available for Android in Google Play. So if you go here, this is the application provided by the zebra crossing team, and you can easily integrate your application with this external app on Android. So instead of using the library, you can, like I'm showing here in this demo, using intent, integrate this external application to your application. So this class here is take care of creating the integration, right, using the intent. So it's launching external activity. In this case, this zebra crossing mobile application, and also this class is responsible for grabbing the results, so showing the application and grabbing to grab the results from the external application. In this case, this application that captures the barcode. So this is how our intent works. In the main farm, we just have, if you go here, we just have one button where you create the class and show the external application, again using intent, and then the results we have here in this method. So if you run this application on the same device, so very similar application, but when we start the camera, we are going to see the external zebra cross up, like you see here, and the value was captured in the same way. Okay, so two ways of that you can use to integrate your mobile application, in this case Android, with library to process barcode, so to capture and process barcode in Delphi. Use the port of the Zebra library, and or using the intent. Okay, so that's it with this library in particular. So let's move ahead and talk about physical device to capture barcodes. So there are a lot of devices available, and the prices ranging from less than $100 up to $2,000 for a good RFID reader. Of course, they have several technology but similar integration models, and this is what we are looking for. For this webinar, we are going to explore 4 distinct devices There are devices used by customers that we helped doing the integration, uh, using three different integration approaches. So we have the keyboard direct input, intents and broadcast, and the Bluetooth SPP. So starting by the keyboard direct input, this is the most basic one because it's available in the most part of embedded barcode scanners. So devices where you have like Android embedded in a barcode um, scanner. Um, they are, of course, very easy to implement. You don't need to do anything. You just put the focus in a data entry control, like a TIAD, and that's it. The device will capture the code and put the code in a buffer inside in your control, inside your data entry control. Uh, the This approach works, but not for all Android versions. There are some old Android versions that sometimes can't just the header can't see your application in FireMonkey. This is probably better now with your native controls for Android. I had no chance to test yet with the native controls and device and these devices, but probably this is now. Uh, um, but in any case, you are not really in control of the application because maybe the focus is not in the right place. This device has a touch screen, so the user can accidentally click in another place, or you can try to control this as well, but it's not perfect, right? And there is a risk of values manipulation as well. So this is the most basic one, but this is not exactly what we are looking for. It's important to know it's possible to do. Don't need to code, but we are really focusing on this intents and the broadcast. So this embedded device, most part of them has this implementation. So it's a concept of Android broadcast and the broadcast receivers. So this is very elegant and it has a really good performance. At the end, you are in the control of your application because you are going to receive your the code in a message inside the application. You can do anything. You can control what's happening. You are going to receive the code even if your application is not in the first plan. So it's very interesting. This links has some information about how to work with intents and broadcasting, especially in FireMonkey and Delphi. So you have the documentation and some samples. But let's take a look on the code. I think this is the best way to understand how this works. This is the first device we're going to look for. This is from Honeywell, this EDA 5th. So we can go to the product page here. You find here all the details, the specifications, some documentation, resources, and etc. So this is the first device we're going to test. Actually, I have a video with this device working with the sample we're going to explore now. So if you go here to the projects folder, so I have one sample for each model here. We already saw the zebra crossing samples. So this is the first one, the EDA 5th. Here we have the product manual. So the very first thing is to configure the device itself. So you need to enable in the device the intent module. So if you navigate in the device to the configurations, remember we are navigating in Android system, so you go to the configurations and there is a special menu that is only dedicated to this to the device or the barcode scanner, the barcode scanner hardware itself. So if we look search here for intent, you see that you can configure the device to send an intent to another application. So basically what we are going to do, I have here a sample of the device configuration, an image of the device screen configuration actually. So you we activate here the data intent feature in device, and you have to configure action. So what is the name of the action? What is the name of the intent that the device are going to send? So this is the first thing you need to do, is to configure in the device the option to send an intent using this action name. Okay, so after that, let's go here to the source code, and we need to edit our manifest and add this intent filter in the intent filter category. So we are just saying here to the application that we are going to receive messages from with this name, with this action name, right? So the device will broadcast a message using this action name. You are going to prepare our application to capture this message. So first thing is to add this new action on the intent filter, right? And if we go to the application source code, we have a class where we are implementing the receiver. So this is the base class for receivers that is declared in the FireMonkey libraries. And it's a very basic class, but just one event here on receive, where you're going to receive the values captured by the device. So first thing you need to do is to create this receiver. So we are creating an instance of this receiver. We are declaring here a broadcast receiver and a filter, right? So we're initializing here the filter with the same name you put in the manifest, and then we register this receiver. So the application is now listening for messages that will be sent with this name, this action name. And finally, here on the onReceive, you just need to grab the value and then of the data. So this is important. Here we have the value it was sent using the name data, or the literal data. So the intent value has several parts or several fields. So you need to look in the documentation for this specific device, or maybe look in a sample that is using the Java SDK provided by the device to find what is the name of the field in the intent that has the data. You need to find this information, or in the manual or in a sample that comes with the device in normally a Java SDK, to understand what is the name of the field that has the value of the barcode, because this intent has other additional information as well. So you just capture this value, right? And if it's not empty, so if there is a value, we are adding here in a list box, right? So if we go here to this folder, I have a video with this device working. So, and capturing some barcodes, right? As you can see, there is no edit or a control in the screen. We are directly receiving the values and adding the values in a list box or in a list view. Okay, so this is how this integration using intents works. There's another device from Opticom, works exactly in the same way. So this is also running Android 7.1. Is another good option for barcode, for high performance barcode reading. So and even in the page we have it's saying Android to 2, the device can be updated to up to Android 7. So the one we used to create this sample to our customer was running Android 7, right? So if we go here to our samples, basically we have the same, exactly same thing. So let's open here this sample. It's very similar. Let's take a look on the sample folder. So we have also the configuration here. In this case, here is the configuration to activate the intent model, right? And in the menu or in the SDK, you can see how to configure the device to use the intent, to send the value using intent. Finally, in the manifest, exactly like we did for the previous device, we added here a new filter, a new intent filter. In this case, the action. This is the name of the action. This is defined inside the device configuration. And in the application, we have the same receive class. So here, create an instance of the receiver, create the filter, initialize the filter, and etc. And here we are collecting the value. So in this case, we found this information in the SDK, in the Java SDK, because it's not in the manual, so it's not so clear. But in this case, the intent, the field of the intent where the value of the barcode is located is this one. So basically, same process. We are grabbing the value from this field and adding the value here in the list box, right? So same way of integration, exactly same way, but two distinct devices, two distinct providers, right? So these two devices with embedded Android, this one and this one, can be easily integrated using and in a very elegant way, in a very professional way, using the intents. Okay, so moving ahead, let's talk about the Bluetooth SPP. So there are devices where you can integrate using Bluetooth, actually using the serial port profile from Bluetooth. So these devices are not devices with Android embedded. Instead of that, they are devices, standalone device that allows you to communicate and receive the values using a Bluetooth connection. So if we go here, we have a list of Bluetooth profiles, and the profile that we are going to use here is this serial port profile, right? So basically, a serial port profile is a kind of socket connection between the device and your application. So if you look to the Android documentation, you have here the information about the Bluetooth socket, and this is what we're going to use to communicate with these devices. So let's start by this device from Bematec. Bematec is a Brazilian company, and this is a barcode reader that can be connected via Bluetooth. It has up to 80 hours of continuous operation, which is very good. So let's take a look on the code. So here is the sample for this one, the BR200. We have here a Bluetooth component. So this button allows you to list the devices that are already configured in your mobile device or even Windows or Mac, because this Bluetooth connection works not only for Android but also for Windows and for Mac. So here we can list the paired device. And here we are going to connect the device, actually creating a socket connection, right? Um, Here you can send commands to the remote device, so you can send commands to start reading, stop reading, things like that. You can see in the manual all the details. And we are using a timer. Right? This timer will receive or check the received data property from the socket by values that the device are sending to you. So we are receiving the values here in the received data and adding the values to our list view. So very basic way of doing this integration using a Bluetooth connection. List the device, connect, create a socket connection, a Bluetooth socket connection, and you can send commands and listen this Bluetooth socket connection to receive the values. So this is how to talk with this kind of device. So moving ahead, let's talk about the RFID devices. So this is a RFID header, a high performance header from Zebra. This device can handle up to 700 tags per second, so it's very professional. You can use it up to 10 hours of continuous operation, and these were part of the requirements from this customer that we helped to create this integration. Uh, so when we start looking to this device, of course, we went to the menu, and the menu points you to a SDK for Android. So this is, of course, a Java SDK, and the was at least at this moment the only way we saw to create this integration. So we start trying to use and import this SDK. By the way, a very large SDK in your Delphi application. But in the middle of this investigation, we discovered basically the SDK was doing it was a socket connection with device and sending and receiving text commands. So uh, this is something that we can do in your framework natively without using external SDK. So if you look here to part of the Java code, you see that they are creating a Bluetooth socket server. And if you go down here, we see a Bluetooth client connection. So basically, we are the integration or the SDK. What the SDK was doing is creating a Bluetooth connection and inside a thread, and where you can keep sending commands and receiving the results at the same time. And we discovered also that all commands used in the SDK, all text commands that the SDK uh, send and receive from the device are also documented here in this ZETI reference. So you have here all the commands and parameters that can be sent and the expected results that the device will send back to you. So based on this and looking a little bit to this Java code, how this were implemented, we create a class, basically a sort connection inside a thread where you can send the comments and receive the results. So let's take a look um, in the code. Of course, this is not the full project. The full project is an intellectual property from the customer. We just helped them to understand how the integration can be done, and they create everything else. But we have here um, the basics or the enough information to understand how the integration can be done, especially for RFID readers. So we have a base class. This class is responsible for implementing the read and the writer. So um, we have here a method to find the Bluetooth device. This is something that need to be done for any Bluetooth connection. So you are going to find the Bluetooth device we are going to talk with. But the most important part is here. We have the header and we have a sender or maybe writer. So the header is executed inside a t-task. So the idea is to run this in parallel, so you don't freeze the application while you are receiving the data. So uh, the header keeps listening in the receive data method, so in the Bluetooth socket port, and while the sender is responsible for sending the commands to the device, right? So of course we have here a stop header to stop uh, receiving the information, and methods to connect, uh, find and connect the device, and here to create this socket channel through the device. So this is the base class. Here we have the connection, creation, and the reader and the writer or sender. So in this another class that was uh, um, a specialization of the basic class, we have the operations itself. So in this one, you can find like operations like inventory start, inventory stop. So let's take a look at how this work. Let's consider we have a socket connection created. So the channel is open. All that you need to do now is to send um, the commands to the device, and these commands basically are text commands. So uh, for example, here we are doing the connection and send this command, this message connect to the device. So the device will be now ready to start operating. Here we have the disconnection. Uh, here we have some configurations. So all of these parameters are configurations that you need to send to the device before starting start the operation. So if you look here, like this key command is set query params and so on. So there are a lot of parameters, and you need to figure out exactly which ones you need to configure before starting the operation. Then we have commands like inventory start. So this we start an inventory, start counting the tags, um, stop or abort, clear. So this clears the buffer of the tags that were already read. Tag finder, this allows you to find a specific tag in a amount of tags. Stop, tag finder, and then process results. So if you look at the base class again, we see in the execute header we have the received data by sleep time. So we wait for some time to grab the data, and then we have this process results. So here is where uh, the results from the device will arrive. So if you are doing an inventory, you are start receiving here the tags of this inventory and so on. So for each command, there is an expected result that's documented in the manual. So like if the operation is the inventory, because when we start the inventory here, we set this operation. So you are in mode, inventory mode. We start the operation setting this flag inventory. So um, here in the process result, if I'm running an inventory, so I can expect a uh, certain type of text or result that the device will send me. So I will put the code here to receive these tags and um, manipulate these tags and create some kind of uh, way to um, persist this information in our main table or a list or something else like that. So this is how uh, you can talk with this uh, device. So the idea is to implement everything else you need here is to look to the SDK and to the manual and create your methods here to send and receive all the commands that you need. But the key is once you have the socket connection create and you are able to send the commands and receive the results, you are done. Of course, there are more code you need to put here, but once you are sending and receiving the data, the, then it's just a matter of adding the rest of methods that are needed. So uh, here in the main farm, there is almost nothing, just sample code about how to use the class. So we are creating the RFID class. In this case specific for this model, setting some parameters, the name of the device that were previously configured and saved in some kind of ini or things like that. So the idea is to read this from a ini file in a dynamic way, and then we have here the open interface, so the device is ready to operate, and then this start button is a simulation about how to start inventory. So we are configuring the device and starting an inventory. So this is how to use these classes that were created here. Let's see this device in action. I have here two short videos showing the final application working with the device. So let's run here, and as you can see, while the device is passing near the items, the application is counting how many pieces are. So the performance is very good, very interesting. Look at the number and the velocity of capturing the items. So these are unique items, right? Here we have another one. This using the other device. Look here how fast it is. Okay, just to demonstrate how this works. So this was how we integrate the RFID reader in a FireMonkey mobile application, in this case for Android. Let me go back to the presentation because we have here two other models that were partially tested. So they are not in operation right now, but they were tested in some way, and they work. They work in a very similar way from the Zebra device. The integration mechanism is exactly the same, just the language or the commands they are going to send and the way they respond to these commands are a little bit different, but the integration mechanism is exactly the same. So two other devices that maybe can be evaluated and used in your project, this .r and BT. So we have the links if you want to learn more about these other two devices, their different capacities and of course prices. So will depend of the requirements you have in your project. So other two devices that can be used for RFID as well. And that's it. In terms of samples and the information we have to share, here you have my email and my blog. And in this GitHub repository, I'm going to share the samples we saw today. So thank you so much for listening, and let's go now for a Q&A session in live. Thank you. Bye bye.